And like I saw it, I was like, "Are you 6 or 7?" I don't want to insult them to say 6 and they're 7.
Okay, I think that the science, what do they call it?
The STEM walk.
The STEM walk was good for people because there was like a lot of more hands-on experiments and
Like
stuff.
you can touch everything, and you could like with the metal,
Yeah,
you could like spray the iron particles on
yeah,
and use the magnet.
yeah, and touch like the stuff that's on the bottom of the magnet and stuff.
And there were like videos of everything, so it wasn't just like them talking. You could actually see what was happening.
Yeah.
We test stuff on bridges, buildings, gas lines, rail industry. We test communication towers. So a lot of the things that you guys do on a daily basis, the roads you're on, the buildings you're in, the gas lines that come to your house, the cell towers you call mom and dad on, we are directly involved with the inspection and testing of those different things. And there's no cracks or anything like that. This guy would pass the welding test. If we bend them and there's a hole or a crack in it, then they fail. So we actually grade people on their ability to weld. So we'll take a piece of metal right out of the middle of this weld, and we have what's called a Sharpie impact tester. It's a 66-pound hammer that swings like a pendulum, and it breaks the metal. And we record. UV Rhineland is a certification and inspection company. We're in 62 countries around the world, close to 20,000 employees. I've had the luck of having to deal with numerous other countries just this past year, from Brazil to Japan, China, Thailand, India, Germany, just to mention a few that I've worked directly with to perform third-party inspections on bridges and pipelines, different things. So
a large release of energy is going to happen here shortly.
There she goes.
Oh my god. I like literally jumped out of my body. I'm not even in my body. I just jumped. I'm lying. He's like, ready?
Here's the molecules in the grain structure. Apply a small load. You can see how the molecules in grain are starting to move around a little bit. If I unload it, they go back to where they started. And here's your linear line for the elastic deformation.
Grade STEM walk, I got a more in-depth explanation about how they test the bridges for scratches and cracks.
Yeah, so when we're polishing it, we want it to look like a mirror when we're all done. When we look at a mirror in a microscope, we don't see anything but light shining back at us. In order to see the microstructure of the metal, mostly steel, we have to etch it. So we'll apply an acid, and that acid eats away at the grain boundaries. And when you shine light on it, it reflects the light and allows you to see the grains. So that's why we polish it. If we don't polish it and we apply the acid, we're not going to be able to see the microstructure.
Maybe one beam welded to another beam. And then we do different tests. We look in the weld to make sure it's the proper microstructure, and we do hardnesses, check the hardness of the welds and different things to make sure it meets all the customer's requirements. And then we're going to go ahead. This is a sample here where I etch just the lower part.
We pre-sanded them so that we can just polish them. You guys want to make your way around to Tim's side.
Light concentration of nitric acid and alcohol. And all you do is you just rub it over this, and you will see it. You'll see it change. You'll see it how it's pulling it out now. Okay, then we just rinse.
So she's gonna hold this like a shotgun. Imagine your little shotgun. Hold it wherever you want. Press the button.
Yeah, hold the bottom with one hand and push the button with the other.
And then you have your number on here. Okay. on how much it.
There you go. It's perfect right now. If you look in there, gather over on this side. You see it? That's what they call the grain structure of the steel.
I liked how in one of the rooms they showed the metal getting cold to the point of breaking, and it made this really loud noise and scared me.
My name's Chris. I work for a company called TUV. We're a metallurgical materials test lab that also does non-destructive testing as well. So some of the destructive testing that we do would be like tensile strength. We would get material in from companies and we would check the tensile properties of, say, steel. We'd pull it apart. We'd measure the ultimate tensile, the yield strength, the reduction of area, the elongation, things of that nature. That's what we call tensile properties. We'd also do things like Sharpie V-notch, check the ductility of the material. We also do procedure qualifications, welder qualifications for welders themselves. And of course what we're going to talk about today is non-destructive testing. And we know we got some holes. Other than that, anything severely wrong with it? Nothing? Okay. So our next step we're going to do is we're going to do a mag particle test. We're going to introduce this is a big magnet. You press the red button, it turns the magnet on. That's all it is. What we're going to do is we're going to use a magnetic energy field and a carrier that's filled with small iron particles to help us see things that perhaps we couldn't see with the naked eye. So we'll go ahead and take a look and see if we see anything else at the plate. Itself is small, it's only right here. The other silver part is what I kept telling you guys about the heat affected zone. So right here's our HAZ, heat affected zone, base, and base. So where's the weld at? Right down the center, that's your weld, that's it. That's the only weld, but we're inspecting all this area because we're worried about the heat affected zone just as much as we are the weld. Okay? So what I'm going to do is this is a big magnet basically. And again, when we inspected this visually, we've seen some holes, we've seen some scratches, we've seen some rust. That was all we've seen, right? So we're going to put this guy here. And we're going to energize her. And this is, like I said, one big magnet when you push that button in. And we're going to put on a little bit of magnetic particle. This dusty powder stuff here is really just little iron particles. I'm going to blow it away. You guys see anything different from what you've seen before? All that stuff is built up?
No, that.
Right there, that's just the particle sticking to it. You just only want to look in this area here. So take a look at that weld now. We've seen the holes. What you have there, that's a whole bunch of small shallow cracking coming off of them holes that you couldn't see with the naked eye. You guys see it all right there? So had we not done a magnetic particle test, we had not known there was cracking at this point. So that's what you guys are looking at. So you can hear the energy right there as I'm putting it on. What I'm going to do is I'm just going to go ahead and simply just spray this down. All this is a liquid aerosol with a whole bunch of little small iron particles in it. Now we're going to take another look at our weld. See anything wrong with it now?
Yeah.
What do you see?
Like there.
Yeah, come on in, guys.
It's like a crack and scratch.
Yeah, there's a lot of fatigue cracks that you would not have been able to see when you guys held the plate itself, correct? After you got the particle on, you have to blow it away, right? You can blow it away like that. Typically, you can use your puffer ball to kind of do it. And the reason you got to blow it all away is anything that's not sticking in them cracks is going to blow away. So now you take a look at your plate that you guys looked at before. Do you see anything different with it? There's a lot of cracks. You can kind of see the purpose of doing a mag particle check now as opposed to it. If you were just doing a visual check on that, you'd have probably said, you know, there's a couple holes, it looks good.
I liked how in one of the rooms they showed the metal getting cold to the point of breaking, and it made this really loud noise and scared me.